technique suit. Impeccable. C'est parti.
Good afternoon, everyone. I'm unfortunately Katrina Vax could not be here, but we are two to replace her today. So I am Amélie Joly, working at EDF DPNT for the direction of nuclear and thermal production.
And I am Stéphane Mulon. I'm a heatsink expert at EDF Engineering.
So today we are going to speak about the ADAPT project, and the objective of the project is to understand how the climate change will impact the nuclear and thermal fleets in the future. And to do so, we are using the latest climate data from the Intergovernmental Panel on Climate Change, IPCC. So what we see on this slide is the average air temperature on the world, how it changed since pre-industrial era. So in blue, it's lower, it's cooler than the pre-industrial era, and in red, it's getting hotter and hotter. So where we are at the moment, we are here in 2023, but around 2022. And what we've seen is that the climate change has already impacted the global warming on Earth. And then looking forward, we have the climate scenarios from very low to very high. So very low is the Paris Agreement scenario. And what we see is that depending on our ability to reduce or not the greenhouse gas emissions, we are likely to face very different future. And what this picture shows, is that we are in a climate drift. However, the greenhouse gas emissions will continue in the future, the climate in the future will be very different than what we know today, and we have to adapt. So if we are looking into into the World Economic Forum report, what we see is that the crises are extremely interlinked in between them, and in order to adapt our nuclear and thermal fleet, we need to understand the systemic problem and build a sustainable adaptation. What we see is that the environmental crises are very linked to economic, geopolitical crisis, societal and technological crisis. If there is a good news in this presentation, is that EDF has been working on climate change for more than 30 years. So in 1990, the IPCC, Intergovernmental Panel on Climate Change, released their first report, and since that date, EDF has been working with a strong R&D team on climate change. Then the summer 2003 was a game changer, and the first adaptation has been made on maintenance, for example. And ever since there has been key milestone, including more and more the climate change risk into the process for safety reason and environmental reason. What we see is that the two smiling people are very great French scientists, Christophe Cassou and Valérie Masson-Delmotte, and they are both on EDF Group Strategy Advisory Committee. So it's very good because they challenge us, and they are also they challenge us, and having them on board help us show how seriously the issue is taken, and they also help us finding the right path into the adaptation process. And as said, EDF has been working for more than 30 years on climate change, and this information is already included in the process within, for example, the 10-yearly periodic review has included climate change impact of how is likely to change the future air temperature, but also the future sea level for the next 20-30 years. And then every 5 years, there is a climatic review, a climate watch, and all of these processes leads to a very robust package in order to keep our plants safe. So And and as you know, we have numerous reactors online, and this is just an example to see how busy we will be over the next few years to see the different yearly periodic review. And one key issue is to adapt as well our approach in order to have the right climate change understanding depending on the horizon we are facing, being the next decade, being 2050, being end of the century for new build. And what we've seen over the last 5 years, unfortunately, is there has been an acceleration of the physical risk of climate change, such as heat waves, and this led to an acceleration in our ability to adapt against the future physical risk. So if there is a key message to learn is that for EDF, climate change has been taken into account for safety reasons for a really long time already, and also for environmental approaches. What has been new within the ADAPT project is to focus on generation and also business continuity, and the local area we depend on in order to operate our fleet. Unfortunately, climate change will lead to systemic problem, but we'll see there's also systemic solutions we can put in place because it's a global threat. And then again, the local environment is also very much more at risk than the facility itself, because the facility has been built and designed to be protected and adapted already for nuclear safety. And therefore, in DPNT, we built a plan that is called SEMA in French, and it means understand, assess, mobilize, and act. And we are trying to understand the future, in order to adapt for the next years or up to 2050, we need to understand how the future might be, but this is a very uncertain future. So how do we act? How do we make decisions in an uncertain future, which is something that is not easy? So we are not working on a new regulatory framework, but we try to have an homogeneous approach and understand how the climate might change. We rely on a very strong internal R&D and numerous partnerships, academics, the army, governmental body as well. And in order to be efficient and work, we really rely on all the existing processes in the business, generation, engineering, HR, purchases. It's a global, the risk of climate change are global, and it needs to be, to mobilize every part of the business. And this is how the work packages of the project has been built. Firstly, in the center, we have the work package 1, which is nature and water resources, because we really, EDF, we rely on the nature, on the water, in order to process with the cooling systems. So this is a big part of the work we are on. We also work on industrial facility. What is also key is all the supply chains we depend on, the logistic, the contract, the work conditions is a subject we are looking into with HR. And finally, it's all the local environment, because we all remember the COVID crisis that led to, if I give the example of the school have been closed during that time, and how do we rely if in the future we'll have 30 degrees in schools, and then someone says we close the school at 30 degrees. How can EDF still rely on their employees to operate? So we are not at all into safety issue, but really much generation and operation. And as said, we rely on a strong R&D. So R&D in EDF is 2,000 people and more. And they help us understand the future of the climate, what is the future climate in terms of heat waves, in terms of drought, rainfall risk. And we are looking into the specifics on our each side. For example, we have both riverside and seaside nuclear station and thermal station. So we are working on different risks of the specific risk of each location. There's a strong work on biodiversity because the biodiversity crisis and the climate change crisis are very much linked together. And working on biodiversity, such as planting trees, will help us both in offset carbon, because the big picture is the net zero. We didn't discuss that, but adapting the climate change, adapting the nuclear fleet is a very important way to tackle, to go and have and manage net zero. We are also working on refrigeration. How will we be able, and this is not only a nuclear industry issue, it's for any industry in the future, how will we be able to produce cold? And there are numerous, I let you read all the rest, but there are numerous R&D programs. And as said, we are very lucky within the R&D to have an internal climate service. So a climate service is a group of people that is it's an interface between the academic knowledge and the industrial knowledge. And it's based on 3 pillars. So the data, they've downloaded thousands and thousands of data, data for observation from the past, modeling from the past and the future. There's also lots of tools that help us transferring the large-scale information from the academics into local information. How likely will be the heat waves in let's say, Golfech? How will be the river flow in Cruas, for example? And this is a key importance. And the final pillar, the most important of all, is the expertise. Because behind these people, you have a very strong knowledge, and that allows us to be with numerous academics as well and build strong relationships. So this is an example about how where is the EDF expertise. So the IPCC gives information of the climate at large scale, and within EDF we have a strong knowledge on how to downscale the information. Sorry, I'm going to drink water. So the expertise allows us to have information on hydrology, but also water uses at regional scale. And this is one specifics of EDF, the climate service. So earlier in the presentation, I said that we need to do to take decisions on how to make investments to get our fleet resilient to the future. But we need to make such decisions with an uncertain future. So you might have seen such figures that correspond to how likely the air temperature will rise in the future depending on different type of uncertainty. The uncertainties, the blue ones, correspond to the scientific and technical uncertainties. The scientific give us models, numerical models, measures of the Earth, combining atmospheric, the ice and all of that. But it's not perfect. But it's the best we have so far. Then we also have our CO2 emissions uncertainty. This depends very much on how we are able to reduce or not the greenhouse gas emission in the future. And finally, it's the natural climate variability that will have let us know that in 2022 we had massive heat waves in France, and in 2023 north of France was led by more rainy, south of France suffered more from heat waves. So this is the variability of the climate itself. We won't have the same climate every 1st July of every year. And what it shows, it's how these uncertainty, the part of each uncertainty, how it varies on time. in the time, depending on the horizon we are looking for. For example, in the central picture, what we see, the blue is the part of the scientific and technical uncertainty regarding to all the uncertainty. So until 2050, the main uncertainty is based on the science. After 2050, in green, the main uncertainty is in green, and this is based on the future CO2 emissions. So the main uncertainty after 2050 depends on our ability to mitigate or not the greenhouse gas emissions. So the pictures in the middle correspond to air temperature, and the one on the left correspond to precipitation, where we can see, for example, that the scientific and technical uncertainty is much higher. It was the worst and most complicated slide of the presentation, so I hope you... Now but it's important, and if there is one key message to understand is that, okay, yes, we have to act depending on those uncertainty, but understanding them and knowing what we can tell and can't tell about them is the key to help us make the right decision at different time horizon. And I mentioned earlier the biodiversity is a key part of our work. And instead, this is an example where we've seen that actually planting trees. So in France, we do have generation loss based on environmental regulation on the riverside. When the Rhone River is too hot, we have a regulatory framework that tells us to reduce our productions in order to maintain the biodiversity as safe as possible. So we do have a very strong research that has started 40 years ago. So we have data of very great value that we discuss with the academics in order to understand how the biodiversity evolves based on the climate, but also based on the EDF, on the generation actually. And what we see is that so the biodiversity in the riverside has varied, but it varied similarly ahead and before, before and after the nuclear power plant, and therefore it's not EDF action that has changed the biodiversity. And what we are doing, what we are looking for, is by planting trees, we are it's an efficient way to reduce locally the water temperature and therefore provide area of refuge for the fishes that we want to maintain. And a strong biodiversity also helps generation because it can it can help having when we need to discharge some chemicals within the river, a strong biodiversity will help and get a better mix, and therefore the biodiversity, we really rely on it. In addition, another example, more on the technical side, is that after 2022, which was that corresponded to the 3 heat waves, big drought in France, we launched a program called E-Cube for investment immediately interesting, and this program helped to first of all also highlight everything EDF was already doing on the maintenance program, and we set up a list of investments that could help us improve the generation of the nuclear plants for the next years. And because in the climate adaptation will vary depending on the time, on the horizon we are facing and aiming. So here if I start with the mid-term, we already have all the 10-yearly periodic safety review that are very strong milestone where the climate change is already included and taken into account to do modification. So this is the midterm. After 2022, we introduced a new program to accelerate additional investment in order to secure all the generation and business continuity in anticipation to the future safety periodic review. And then on the long term, with the aim of increasing the lifetime of the plants, additional investment will be needed. And as drawn by the arrow, the complexity of the investment will increase in time, also because, and this depending on our ability to reduce our emission scenarios. And a quick focus, and then I will lead the time to my colleague Stéphane. On the water resource, we worked both on the quality, the quantity approach, and the qualitative approach. So these are examples of the investment we are making at the moment to reduce the quantity of water we use, and also to improve the quality of water used. And the first step on the quantity is very much providing a diagnosis on having a very clear understanding on how we use the processed water, how we use it, how can we track any leaks, for example. And then we're working on reducing this water and also reusing water plums, for example. On the quality, we work on the co-recycling and also optimizing the radioactive effluent and improving the monitoring of the environment around the plants to understand, to have a very deep knowledge on what we are doing. And this is my final word. It's also that. So this was a focus on nuclear in France. And what we can see looking worldwide, where there's already nuclear plants in different climate very different than the one in France, we can see that nuclear facilities can be adapted. But to do so, we need to have a strong cooperation based on scientific approach, and also understand the systemic risk, and we need to tackle these challenges with pragmatism. And I thank you, and I lead you to conclude.
Well, so we've got the second part here. Before starting, I would like to say that I'm happy to see that there's many people, because 5 minutes only. How is it possible? Well, because everyone hears about climate change almost every day in the news media, so we understand why there is a great success to this workshop. So I will try to go as quick as possible. The aim of this second part was to give concrete representative examples of how climate change is taken into account in our design, and especially on the heat sink design. Why the heat sink? Because it is an essential interface with the environment. So I guess everyone knows that the nuclear power plant needs cooling, and we often rely on the water of the natural environment. The main cooling need is the condenser, order of magnitude 40 to 60 cubic meters per second, and that's very important. And climate change has an effect on this water, increase of water temperature, increase of sea level, and in case we are in riverside, sometimes scarce freshwater resources. Amélie said that even before climate change was highlighted, EDF has always been analyzing, studying these effects. It's through the topic of external hazards, because the power plant has to be robust to prove its safety, and because its environment, the environment has to be protected. So very concrete solutions against the increase of water temperature. Well, the answer is an appropriate sizing of the cooling chains. This means choosing the appropriate heat exchangers and the pumping flow rates. And even in our existing French fleet, when we reassess every 10-year safety, sometimes we had to increase the capacity, adding plates to exchangers, or increasing the flow rate of pumps. We talked about water, but we have to also take into account air temperatures, because all the buildings, including HVAC, including heatsink buildings, has to be able to face very high air temperatures. So this is done via an appropriate sizing of HVAC systems. We perform thermal calculations in the plant rooms, taking into account all the calorific contributions of the equipments, and then size the ventilation flow rates and the chillers, and add mobile chillers when needed. As for the seawater level, the design, what is very important in the design is the appropriate choice of the plant platform altimetry. And to do this, we take into account many different components. Of course, the maximum tidal coefficient, but also atmospheric depression, wind and waves effect. So this enables to choose an appropriate plant platform altimetry. And we also had to add dikes, including after extreme events or after 10-year reassessments, like you can see examples in the Blayais NPP or Gravelines NPP in France. One very accurate question is the question of freshwater resources in Riverside. The first answer is to choose the appropriate architecture of the heatsink, and especially moving from once-through cooling systems towards recirculating cooling systems. This has two main advantages. First, the flow rate withdrawn from the environment is a lot lower, because it's only needed to withdraw the cooling tower makeup and not the whole cooling flow rate for the condenser. And the second big advantage is a lot less thermal effect in the river, because in this case, the mean heat exchange is done towards the atmosphere. There is, when you introduce cooling towers, you also introduce water consumption, which is not the case with one-through cooling systems, because the heat exchange is done through evaporation in the atmosphere. And once again, to give an order of magnitude, this is for power plants less than 1 cubic meter per second. So very often, that's very small compared to the flow rate in the rivers. And this is the solution, which is, yeah, just 2 minutes. And, yes. We understand. So this is implemented on all our units in France, and that is 30 units in 7 different rivers for the recirculating cooling systems. And even if there are extremely lower limitations, there are other most sophisticated specific solutions, such as decreasing the blowdown of the cooling tower, and that is increasing the quality of water, adding chemical facilities, and to decrease the evaporation of the cooling towers, That's with using hybrid wet and dry cooling tower technology. As for the thermal limitation, there are also, we've done this in Civaux in France, we can add also specific blowdown cooling towers, and this enables to decrease the water temperature before it returns to the environment. Okay, I will skip this one just to give the main message is that there are solutions depending on what is more important. I mean, if water consumption or water withdrawal or thermal effects is the more important, there are different kind of solutions. Each solution has advantages and drawbacks, and I think the EDF engineers know this and are able to explain and design the appropriate solution when we have the appropriate set of requirements. Thank you very much. I'm sorry we are very short on time, and we were said that if people